All right, so today you're going to do a Cambium practice test. So basically this is going to be a review of all of the different topics that we have covered in Unit 1, except it's in Cambium, which is the same place that you're going to take your actual STAR assessment. So the first thing you're going to do is highlight this link and copy and paste it. So Control C is your shortcut for that, and then Control V. So once you get to that link, you're going to scroll down to this where it says online practice tests and click on practice tests login. You don't have to do any of this stuff. Just go ahead and click on sign in and select 9th grade, STAR practice sets, and then scroll down. We have to go quite a ways to mathematics, 2021 mathematics, STAR new item types. So that's what we are going to be practicing. So this is all of the new item types, nothing that is multiple choice. And then this is all just information that you have to go through when you're actually taking the state assessment. You can read through it if you want to. I'm just going to go ahead and click on begin test now. So this is the practice test. At the end, it will give you a score, but we're not really focused on that. This is really just one, you can see how the graphing is different on this than it was in Eduphoria graphing that you did yesterday. But then you can just kind of see the different types of questions and how to type your answers in because it's different than Eduphoria, even though Eduphoria is kind of close. So you have a worksheet in front of you that looks like this that you should be going through also as I'm going through this practice test. Oh, here we go. So if you look at your worksheet, it says to divide exponents with the same base, you must blank the powers. So remember when we're dividing, we subtract the powers. And then then it just says the answer is, so you're going to go through and subtract. So remember this is 6 minus 1 because this has an exponent of 1. This is 1 minus 2, which is negative 1. And then 7 minus 2 is 5. And then go ahead and simplify that. Question 2. This is a quadratic function. What is the equation for this function in standard form? So this one is not very nice because it doesn't say equivalent. This one is asking you just to rewrite it in standard form. So remember to do this, and I'm not going to write all the steps. I'm just talking you through the worksheet here. So it says you must square x plus 4, this part right here, square x plus 4 first. Use the box method because you're going to end up multiplying x plus 4 times x plus 4. That's what this means, x plus 4 squared. So when you're filling out your answer sheet here, you must square x plus 4 first, use the box method, then, I think it's subtract, let me go back and look at it, then subtract 18. From whatever the other number is, subtract 18. And then go ahead and write your answer in the box provided. And then on the form, you should also write your answer. It says standard form of the quadratic function is. Go ahead and write your answer as well. Number 3, remember to solve an equation with one variable, because these are all just m's, you can use Desmos. So on your form here, you're writing y equals, this should be the left side of the equation, and y equals the right side of the equation. You're actually writing it in. So y equals 6 times 4m minus 3 plus 6. That should be one of your equations. And then y equals all of this. So remember, what you are looking for is the intersection. You're looking for where do these two lines intersect. And then it says the solution is the x value. The solution is always the x value of the ordered pair. Oh, so it should say the solution is the x value of the intersection point or the intersection. Number 4, this is just find the rate of change. We've done this a lot. You're just y2 minus y1, x2 minus x1, divide them, enter your answer. So we're not going to practice that one. We've done that a lot. Number 5. So this is one of the graphing ones. The first thing you have to do is select the type of graph. So is it linear, quadratic, or exponential? So what I recommend is type this in Desmos and see what it looks like. Does it look like a line, a parabola, or something like this? So you should know that because the x is in the exponent, it's called an exponential function. And then it says drag the 2 points and the asymptote if applicable. So that means sometimes you drag the asymptote, but if applicable means if you have to. So in this case, we're not going to have to move the asymptote. Let me see. So this type of function, I'm going back to the paper here, this right here, number 5. This type of function is exponential. Place the first dot on. So what you would do is look at the equation. Remember, from this equation, this is your y-intercept unless there's a number added on to the end. So find your y-intercept first. And again, you can graph it in Desmos. Let's go ahead and graph this in Desmos. 6 times 2/3 to the x power. Okay, so you are looking for the y-intercept, which is 0, 6. So you're going to want to move this up to, oh, not that one. I'm just going to move that out of the way. Move this up to the 6, and then you just need to find another point. So the easiest way to do that is click on this, go to settings, change it to a table, and you're looking for another whole number value. So we have 0, 6, but right here we have a 1, 4. So that's the one we want to graph, 1, 4, which is right there. So go back to the test, 1, 4. And then notice the asymptote where this starts to level out is along the x-axis, which means we don't need to move the asymptote. All right, number 6. Oh, I answered that one, so I didn't have to click yes. So as you're answering, unless you skip the question, you shouldn't have to keep clicking yes. Number 6. So again, when it's a graph, you have to figure out which type of function it is first. So you have f of x equals x squared, and then a transformation. This does not have an x squared, but if it was transformed from this graph, then it has to be x squared. So basically it's saying you're taking this function f and changing it. So what you're going to do is you're going to type both of those in Desmos. But this one, you can't change the f of x to a y. You have to leave it as f of x. So f of x equals x squared. This is what we call the parent function. And then the other function is g of x equals negative f. So that's because the f is here, that's why we have to keep the f in the first one. So negative f, x minus 3 plus 4. G of x equals negative f, I think it was x plus 3 minus 4. Minus 3 plus 4. Here we go. So notice they're parabolas, which means, so again, if you don't know what they are from looking at it, once you graph them, they don't look like that and they don't look like that. That lets you know it's a quadratic. So all we're doing is graphing. It says, what is the graph of G? So what is this graph? So once you type both of them in Desmos, now so you have to recognize, first of all, this is the parent function. This is the blue one or purple, whatever color that is. And this is G, the black function. So you're going to need to find the vertex. That's one of your key features. So I'm going to move the vertex first. Where is this? Number 6. So this type, I'm going back to the worksheet here. This type of function is quadratic. The transformed equation is quadratic. They both have to be the same. Graph both equations in Desmos exactly as they are written and find the vertex and one other point. So place the first dot on the vertex, which in this case we said was 3, 4. Sorry, I have too many tabs. So place the first dot on the vertex, 3, 4. Place the second dot on anywhere else that's a whole number. So either of these 2 points would be okay. Even this point, as long as it fits on the graph here, yeah, any of those points would work. So you move this to 3, 4, and then your vertex, was it 1, 0? Yeah. And it goes through 0, -5, and the 5, 0. So you know it's the right graph. Number 7, on your paper, what does a line of symmetry do? So a line of symmetry, remember that cuts it in half. So its equation, if you remember back to our supplemental aid on the reverse side of it, the reference materials at the very bottom, it says axis of symmetry, and then it has this formula, x equals -b over 2a. All I had y'all do was circle x equals because I want you to remember that it's x equals, always. So, sorry, I went to the wrong thing. So when you're looking at this, so understand the axis of symmetry has to cut it in half. That means this cannot be the vertex because that does not split these 2 points in half. It has to be, your axis of symmetry has to be in between these 2 points. So it has to be right here at x equals -2. So this one's kind of tricky because they gave you a point that's not the vertex. So x equals -2. If you're given a graph where it doesn't give you the vertex, you're just find 2 points that have the same y value, and you're looking for the middle point, which is -2. So this says the 3 points the 3 points shown lie on the graph of a quadratic function. Graph the line of symmetry for the quadratic function. Select 2 points on the coordinate plane, a line will connect. So you click on 2 points that are on that line of symmetry. So here's one, and then just click on another one. And it's going to show you that's your halfway point right there. Number 8. So you should be on page 2 as you're working through the worksheet here. We're on page 2. So the first step is to solve for y because I cannot graph this function in standard form. So solve for y, which again means we have to subtract 3x. So we're going to have 15 minus 3x and then divide by -5. So 15 minus 3x all over -5. I'm going to go ahead and graph it on here. Y equals 15 minus 3x all over -5. So I have my graph, and all I have to do is graph it. Select 2 points, and a line's going to connect them. So one point we should always select is the y-intercept, as long as it's a whole number. And then, look, the x-intercept is also a whole number. So graph those 2 points, connect them. So on your paper, it actually is going through, like, if you have it in slope-intercept form. So y equals, what would that be? Your slope is going to be +3 over 5 if you were to simplify this, because that's in front of x. So +3/5, and then -3 is your y-intercept. So y equals 3/5 x minus 3 would be your equation if you're writing it in slope-intercept form. So the first dot will be on -3, which is your y-intercept. Now count, was it 3/5? Yeah, 3/5. So rise over run, up 3, and to the right 5, and plot that point. But again, you don't have to do that. You can just graph it in Desmos and pick 2 points and plot them. Number 9. To graph the system of inequalities, so I'm reading this paper here. To graph the system of inequalities, follow the instructions given. Notice that the color of the dots and line match the box, and then sketch the graph below. So I have a little reminder here. So remember, it's a solid line for, I'll write this down because some of y'all get confused with the inequality symbols. It's a solid line if it's less than or equal to or greater than. So the extra ink in the symbol means extra ink in the line. Dashed line if it's just less than or greater than. You shade above if it says greater than or equal to. And below if it's less than. Less than means below. Oh, less than or equal to. I wasn't supposed to put that last line there. My eraser's not working. Oh, there we go. All right, so you should have that filled out on your paper. So now let's go back to the test. What is the solution? So these are already in slope-intercept form. If you want to, you can graph them in Desmos, but remember you have to use, you have to type it in as an equation. So y equals negative 3/4 x plus 4. Let's type that in real quick. Y equals negative 3/4 x plus 4. So notice it's a line, but if you look at the inequality, since it says greater than, it should really be a dashed line. So what I'm going to do, I'm going to graph the first one, and I have to click on dashed, and then I'm going to pick, here's 4, and I can't graph that one. So what I could do is look at the table. 0, 4, I'm already graphing. It doesn't give me any whole numbers, so I got to find another whole number. There we go, 4, 1. So those are 2 points I can graph, 0, 4 and 4, 1, and that's one of my lines. But then remember, you also have a shaded area. So because this first one says greater than, then the above portion right here, you just have to remember that. And if you bring an expo marker, you can kind of color that portion of your graph in. And then graph 2 is also, it's less than, so that means it's also going to be dashed. And I'm going to graph this one using slope-intercept form. So negative 5 is my y-intercept. But you could do the same thing we did on the first one. Just graph it in Desmos, pick 2 points. Oh, I didn't do that right. 4, 1, I think. I have to click on this one, I guess. So negative 5 is the y-intercept, and then 3/2, which means I go up 3 and to the right 2, click a point. So there's the intersection. But again, we're supposed to be graphing the solution set. So now you click on solution set. Remember we said this is the region shaded on the green line. And then for the pink, it's less than, which means all the numbers underneath that line, which is this region. So if it's one of these 3 sections, it has to be the overlap. This is the overlapped area. So if you don't remember that, let me actually write that on here for you. So since this one was greater than, actually I'll do that since I have pink here, I think. I don't know what I have. This line was less than. So remember you go to your y-intercept, less than means below. So this is the shaded region. And this one said greater than, go to your y-intercept, greater than means above. So this is the shaded region on that line, and we're always looking for the overlap, which is this area right here. So then when you go back, solution set, that's the region you have to click in. Your answer is not complete if you don't actually shade part of it. All right, we're on number 10. So again, if you look at your paper here, the first step is to solve for y. If you don't have an equation that's in slope-intercept form, then it's always your first step is solve for y. So I gave you some reminders here. Actually, no, I didn't on number 10. So it just says y is less than or equal to, so go ahead and solve. Again, subtract 5x, divide by 6. So solve for y, and then follow the instructions. Don't forget to click on solution set. This is on your paper. Click on solution set to shade one side or the other. So again, it's the same thing, except it's just one graph. So you decide whether it's solid or dashed, graph the line, and then click on solution set. Right now it's graphing the whole thing because there's nothing there. Number 11. So you have to solve this. So remember, you can do that using Desmos. You have to cut this in half. Y equals the left side, y equals the right side, and that will give you the number. And then notice my sign's flipped. Instead of greater than or equal to, it's less than or equal to. And the reason is because my the value of the variable on the left side is smaller than what's on the right side. So when I distribute this, this is a negative 6j. That's smaller than 8j. That means my sign is going to flip if the left side is smaller than the right side. The reason for that is because you're eventually going to have to divide. So you're going to have to add 11, move the 8j to the other side by subtracting it. Then you have negative 6 minus 8, that's more negative. You're going to have to end up dividing by a negative. So remember, flip the sign when you divide by a negative. That's what goes in this blank. Flip the sign when you divide by a negative. Is the point going to be closed or open? So remember, extra ink in the symbol means extra ink in the point. So closed. And which way do you shade? Since it says less than, you shade to the left or below. In this case, it's a number line. So what you have to do here, and I think I also have this, choose the correct dot with the direction. So we said it's going to be a closed circle, so it's one of these two, and we're going to have to shade left. So you click on it, and if you clicked on the wrong one, you just click remove. So if you accidentally clicked on that one, just remove it. So you have to decide which kind of dot and which direction you're shading first, and then you just move this dot. So whatever the number happens to be, I'm going to let y'all figure that out. Again, you can use Desmos to find the number. Okay? And then just move the dot where it's supposed to go. Number 12. Repeat what you did for number 11. So it's the exact same thing, except again, we're going to have to distribute negative 2m, and this one is positive m. M is bigger than negative 2m, which means the sign's going to stay greater than. And because it's just greater than, it's going to be an open circle. And greater than means to the right. So we're going to shade to the right. So this is the arrow, and then you just choose which number it should go on. Number 13, follow the directions given. And then on your paper, you're just writing in, it says the function has a blank value of blank. So you're just writing these on your paper that you're going to turn in. So this is asking for a max or min. This is a highest point. That means it's a maximum. And then what's the value? Your max value is always going to be your y value, not your x value. So you're looking for a y value because remember, think highs and lows. That's up and down. That's y-axis. Number 14. So on your paper here, I gave you a reminder that y equals a times 1 plus r to the x power. This is like your standard form for exponentials, where a is the initial amount, a is where you start at, and r is the rate of growth in this case because it's plus r. If it said 1 minus r, then it's a rate of decay. So then it just says, what did you choose for the three blanks in order? So just write what you choose. So the initial population is, so use what I just told you, where A is the initial amount, and R is the rate of growth, the percent that it's growing. And the population is increasing or decreasing. Remember, if it's plus a number, 1 plus something, or if this number is bigger than 1, then it's increasing. And then the rate is your R value as a percent, because you always have to change it to a decimal. All right, so now we're on the third page, number 15. And again, we see the first step is to solve for y. That's always going to be your first step, solve for y. Because if I want to graph this, I need to know what it looks like. So notice it gives me an equation, and then it says which points are in the solution set of this inequality. They changed the equal sign to a less than. This is really tricky because if you look at this graph, it's a solid line. And obviously, if it's a solid line, then these two would be the correct answer, right? But this should not be a solid line. So again, if you have your expo marker, I would draw a dotted line. So you remember when you see that this is dotted, not solid, and it cannot possibly be these points on the line, because if it's just less than or just greater than, then a point on the dashed line is not part of the solution. So it cannot be those 2 points. So it's either the two above it or the two below it. What we have to do is figure out, am I going to be changing this sign from a less than to a greater than? So to decide, we have to think about what we're going to be doing. Are we going to be dividing by a negative? So we have to subtract 4x and divide by positive 5. If the number in front of y is positive, that means you're not going to divide by negative, so it's going to stay less than. So less than this would be anything below it. So select your two answers. 16, the two zeros are, so first of all, on your paper, you see a z equals s equals xi. I wanted to remind you about, I forgot to talk about this. So I talked about it, but I didn't talk about it on the paper. A point on the dashed line is not part of the solution. So I said it, but I wanted to make sure y'all got it on your papers there. A dashed line is not part of the solution. Okay, back to 16. The two zeros are blank and blank. So again, zeros are solutions, which are x-intercepts. So write that in on here. Make sure you know that zeros are solutions or are x-intercepts. So this question says, what are the zeros of the function? All you have to do is click on the x-intercept. So you have to know here that zeros are x-intercepts, where that graph crosses the x-axis. Okay, fun one here. Number 17. What is the factored form? And this is not multiple choice. If this was multiple choice, you could just type this in Desmos and all of the multiple choices in Desmos and get your answer. This one's not that great. So we actually have to factor it. Notice there's a number out here. That means there is a GCF. So on your paper, it says, is there a GCF? Yes, there is a GCF. What can I divide all those numbers by? Well, the smallest number is 2, and I can divide all the other numbers by 2. That means that's my GCF. So I'm going to take out a 2. I'm just going to write it here. 2. And what's left is x squared minus 7x plus 12. So again, I get that by dividing. 2 divided by 2 is the 1. 14 divided by 2 is 7. And 24 divided by 2 is 12. And I just left the signs that were there. So once I do that, now I notice there's still a trinomial. So I use the x method. Remember, the x method is a times c, which is 1 times 12. And then b, negative 7, goes in the bottom of the x. So I need two numbers that multiply to 12 and add to 7. So it happens to be 3 and 4. They're both negative because they both have to have the same sign. Since this number is positive, same sign. This tells me they're both negative because they have to add to a negative number. So negative 3 and negative 4. So it already has the x here. I know these boxes are like bigger than the x's and they shouldn't be, but that's just how it is. So we have negative 3 and negative 4. I'm actually going to drag them down here. So x minus 3, x minus 4. Now that you have your answer in, what I would recommend is go to Desmos, 2x squared minus 14x plus 24, and type it in. 2x squared minus 14x plus 24, I think. And then the answer we got was 2 times x minus 3 times x minus 4. And they should be exactly the same. So toggle on this to see that they're exactly the same. Always do that. Check your work in Desmos. Number 18. So what are the equation and slope of the line? So this is just a drag and drop. You have 3 equations, type them in Desmos. That's the easiest way to figure out which one is exactly the same as this. Type them in Desmos. And then for the slope, remember you have the slope thing, positive, negative, 0, and undefined. So choose which one is the correct slope. Number 19, circle the functions. So remember our supplemental aid where we had the big circle with the dash through it, and it helped us remember that no repeating x's means it's a function. So if there are no repeating x's, it's a function. Also, the vertical line test. So if it gives you an equation like this is a linear equation. Type it in Desmos, see if it passes the vertical line test. If there's a line you can draw through it and it goes through the function more than once, then it's not a function. And then if you're looking at a table, you're looking for repeated x values. Again, here's a graph. You're checking this using the vertical line test. All right. Number 20 is a yucky question. We're skipping it. I did not mean to click save. No. Okay, good. Number 21. We have 2 more questions. So first, I want y'all to recognize, so you'll see questions like this on the STAR test where you have to answer multiple select, and sometimes it'll say select 2, sometimes it's select 4. So pay attention to how many it tells you to select. So on your paper, it says how many correct answers are there. You should say there are 2 correct answers. What are the domain and range for this function? So first of all, look at all of the domain values. One of them you should be able to strike out really easily because domain is x values, not y. So it's either all x values greater than or equal to -9, or it's all real numbers. So again, graph this in Desmos. But if you have a parabola, it's a quadratic function, it looks like a U, its domain is always all real numbers unless there's context. And then your range, remember, think about what this graph is going to look like. So if I graphed this in Desmos, this is going to be open up. And this is actually in vertex form. So we should be able to tell what the vertex is. Remember, it's h comma k. So h comes out as opposite, -9, and k is this number at the end. So the vertex right here is -9, -8. This is the y value we're looking for. So when you're looking for the range, it can't be x because it's range, and range is y values. And the range is never all real numbers, so you know it has to be that one. So that makes it pretty easy if you're narrowing out some obvious wrong answers. Range is never all real numbers, only for linear equations. It's never all real numbers for exponential functions or for quadratics, the other two functions we've talked about this year. There we go. And last question. Again, it's a multiple mark. So on your paper, it says, how many correct answers are there? There are 3 correct answers. So this one is giving us another function in function notation, f of x equals and g of x equals. So what I want you to do for this one is graph them both on the same grid, the same Desmos screen, and then see which 3 it is. So remember, each of these numbers does something. So this one, you are, let's see. Three correct answers. So remember, the a value is what makes it like steeper or less steep. So you have to determine which one is less steep. In this case, g of x is 3/4 instead of 1. That's less than 1. So it's actually, so g is less steep, but that's not one of your options. So you would have to go backwards and say, okay, f is steeper then. And then it's being translated either 4 units left or 4 units to the right. So remember, it's always the opposite. So because this is 4, that means we had to plug in a -4. So it's 4 units to the left. And then this one's even asking about the x-intercept. So if it was moved 4 units to the left, that means the x-intercept is going to be 4 units to the left. But again, use Desmos to help you out with that one. So I think once you click, so I have some not answered, obviously, but once you click submit, it will show you a score. There we go. So does it tell you? It doesn't give you a percent or anything. But if you want to write at the bottom of your paper how many you got wrong, that would be helpful. All right, so this was a really good practice of a bunch of different things you're going to see on the test. If you have any questions, you can email me, and I might be able to get to them. But you can also ask Miss Carey or Miss Therian. If they're not in there today, then they'll be in there at some point. Please ask them questions. Utilize them. They know their math. Have a good rest of your day.